All right, tonight's lesson's on parallel lines and triangles. So we're going to start talking about triangles and relationships within triangles and how parallel lines relate to them. So go ahead and do your review section. We're looking at the word alternate. When we talk about alternate exterior angles, alternate interior angles, but we're going to work for go through some vocabulary words dealing with the word alternate. And then our vocabulary builder tonight is the prefix tri. So tricycle, tripod, triangle, and you're going to answer 4 true-false questions on the prefix tri. So go ahead and do that now, and we'll begin our lesson here shortly. All right, we're going to start the lesson with the parallel postulate. Another postulate, there's just so many to learn. You need to make sure you're writing them down in your theorem sheet and you're keeping track of them. Through a point not on a line, there is one and only one line parallel to the given line. So if I have a point P, there's only one line and another line L. There's only one line that goes through a point P that will be parallel to L. So we can draw one line through P parallel to L. The sum, theorem 310, this is our first theorem about triangles. It's an important theorem. The triangle angle sum theorem. Y'all have known this forever and ever, but here we go, there's a theorem. The sum of the measures of an angles of a triangle is 180. So in number problem 10, we have a triangle that has a marked angle of 100 degrees and 30. So we add those together, get 130, subtract them from 180. So the measure of angle C is 50. Similarly, in problem 11, we have a right angle, which is 90. So when we have a 90-degree right triangle, the other two angles add up to 90. And since angle M is 45, the measure of angle L must be 45 also. So we can use the triangle angle sum theorem to solve problems involving triangles and their angle measures. So we're going to look at the diagram at right, and we're going to find the value of Z. The measure of angle A is given as 59. The measure of angle ABC is 43 plus 49. We add the two angles together, and we get 92. So BD is a angle array that, or a segment that cuts into the angle, so we can use the angle sum theorem to add those together, angle addition postulate to add those together, and get 43 plus 49 equal 92. The measure of angle A plus the measure of angle ABC plus the measure of angle C, it's the big triangle, equals 180. Measure of angle A, we've already said, is 59. The measure of angle ABC is 92, and we want to find Z, or angle C, which is Z, and all those equal 180. So now we're going to take 180, subtract 59, subtract 92, and we get 29. So the measure of, or the Z in the measure of angle C is 29. Now there's another way that we could have found Z to solve for Z. There's more than one way to solve problems in math. This time we're going to use the variables x and y. So we're not only going to solve for Z, we're going to solve for x and y. So first we're going to find the measure of BDA. Measure of angle A, measure of angle ABD, and the measure of angle BDA equals 180. We know that A is 59 and ABD is 43 and X is BDA. So we're going to subtract 102 from 180 and we get that X equals 78. Now, X and Y form a linear pair. So the measure of BDA plus the measure of BDC equals 180. They are supplementary angles, they form a linear pair. So we say X plus Y equals 180. But we've already solved that X equals 78, so we're going to subtract that from 180, and we get that Y equals 102. Keep this in mind, because later on we're going to have an exterior angle theorem, and as you can see, Y equals B, angle B, and angle DBA, excuse me, and angle A added together. As we can continue on, let's now solve for Z. We know that Z plus measure of angle CDB plus the measure of angle BDC equals 180. I think I did make a mistake. That should be CBD. That one's not as easy to correct, but let's try to correct that. Okay, now we're correct. Z plus the measure of CBD plus the measure of angle BDC equals 180. That's the triangle to the right. And we know that the measure of CBD is 49, and we just saw that the measure of BDC is 102. So those added together equals 180. So Z equals, and it's hidden here behind my little thing, Z equals 29. So we solved the problem for Z two different ways and got the same answer. All right, let's look at another theorem, Theorem 311, which is the triangle exterior angle theorem. An exterior angle of a polygon is an angle formed by a side and an extension of adjacent side. So this is the angle. It's formed by the side of the triangle and extension of the adjacent side. For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. So in the picture here, 1 is the exterior angle, 2 and 3 are the remote interior angles. So the measure of each exterior angle of a triangle equals the sum of the measure of its two remote interior angles. This is Theorem 311. So measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Now we're going to circle the number of each exterior angle and draw a box around the number of each remote interior angle. Go ahead and do that. I'll give you a few seconds. So in our drawing, 3 is the exterior angle, 1 and 2 are the remote interior angles. Let's look at problem number 20. 4 is the exterior angle, 5 and 6 are the remote interior angles. So let's use the triangle exterior angle theorem to solve a problem. First thing we're going to do is we're going to follow instructions here. Two angles of a triangle measure 53. What is the measure of an exterior angle at each vertex of the triangle? Label the interior angles 53 degrees, and A. We know that the two angles are 53 degrees at the bottom because we have the congruent symbols, so they have to have the same measure. Label the exterior angles adjacent to 53 degrees, X and Y. So there's X, there's Y. And label the third exterior angle as Z. So we're going to use the flow chart below to answer the questions. First, we use the triangle angle sum theorem to solve for A. 53 plus 53 plus A equals 180. So A equals 180 minus 106 are 74. Using the exterior angle sum theorem, we're going to solve the next three problems. Okay, X equals A plus 53. So we know A now equals 174 plus 53. So the measure of angle X is 127. Y, likewise, equals A plus 53, or 74 plus 53, 127. And finally, Z equals 53 plus 53, or 106. And I think if you add up all three of those exterior angles, they're all going to measure 360. And again, that's something to keep in mind for the future because we have a theorem about that also. Problem 3, applying the triangle theorems. Can you find the measure of angle A without using the triangle exterior angle theorem? Angle ACB, and DCB are supplementary. They're a linear pair. The measure of ACB is 180 minus 80 equals 100. Can you find the measure of angle A if you know the two angle measures? Yes. We use the triangle sum theorem. So the measure of angle A equals 180 minus 100 minus 30, which equals 50. All right, so to finish out the lessons, you need to complete your lesson check, And we will go over that when you come into class on tomorrow, whatever day it is. I think it's going to be Wednesday, I hope. And I recorded 2 videos. That's why I think we're going to get through this one tonight. So if you think I'm crazy not knowing what tomorrow is, that's why I'm questioning that. Complete your lesson check, and we'll go over your introduction. Here are the review questions, which I forgot to do for the previous video. And here are your answers to the second part. It goes true, false, false, true. And we will go over your answers to the lesson check when you come into class tomorrow. I hope you have a good evening and good night.